Hi everyone and welcome to today's video where we are going through 8 of the latest questions from meteorology. All of these have been seen across all EASA authorities in the latest exams, so let's just go through them. I'll try to give you some tips, extra information, and the explanations for these questions. So for question number 1, which of the following is required for the term CAVOK to be used? The CAVOK is an abbreviation for clouds and visibility OK. We use this essentially when the weather is really good and it is not a worry or should not be concerned. It should not be a concern for us flying. But CAVOK is a term that is legally described as a couple things that we need to remember. This is one of the questions that also a lot of examiners and instructors like to ask their students during the flight phase of the training. So make sure you remember very well what CAVOK is. The CAVOK, generally speaking, means that there are no clouds below 5,000 feet or the MSA, whichever is higher, the visibility is 10 kilometers or more, and there is no significant weather or clouds in the vicinity of the aerodrome. So this means that there cannot be any cumulonimbus or towering cumulonimbus clouds, no clouds below 5,000 feet. And of course here we're talking about the ceiling and also the visibility 10 kilometers or more. So of course here this answers no clouds below 5,000 and no CBs or TCUs is the correct one. However, do not forget about the MSA part, because if the MSA around your airport is, let's say, 7,000 feet, then the 7,000 feet will be the higher one, or the 3,000 feet, depending which is more restrictive for your flying. Now for question number 2. An aerodrome on the coast of Faro, Portugal reported the following METAR. So we have the Faro airport at 7th of the month at 6:50 Zulu. The wind is blowing from 260 degrees 15 knots. And then we of course here have 100 meters of visibility and fog reported with no vertical visibility reported. The temperature is 5, dew point 5, and the QNH, which is the pressure at the mean sea level, is 1006. So what type of the fog we can expect in Faro? Generally speaking, if the winds are relatively strong, the only fog that we can expect is the advection fog. This is the fog that is being brought by the horizontal movement of air. So in this case, we have warmer air brought over a colder piece of land, and then it saturates and we have fog. In order for this air to be moved, we need the horizontal movement, which is of course the wind. Generally speaking, for advection fog, 15 knots is the maximum limit over land, and 20 knots will be the maximum limit over the sea. However, if you ever see a coast in the question, in most cases the coasts are very closely linked to advection fogs, especially for the exams. So remember, if you see a coast or a coastal airport, in most cases the advection fog will be the one. Radiation fog, on the other hand, for example, can only exist in very low 3 to 5 knot winds maximum. And for radiation fog, always try to look for the keywords such as a cloudless night or very low winds. For orographic fog, try to see if the wind is blowing perpendicular to the mountain range, as in these cases the orographic fog is very likely, as the air is being pushed perpendicularly towards the mountain range, goes up, cools adiabatically down to the saturation point, and we have the orographic fog. So just a couple things to remember when it comes to the topic of fogs for your MET exams. For question number 3, which of the following sets of conditions are most favorable to the development of thunderstorms? Generally speaking, remember that thunderstorms need a couple of very clearly defined things to be created. First of all, we need at least 10,000 feet of unstable air above the freezing level. We need moisture and humidity in the air, and we need something called a trigger. Trigger is the initial uplifting force, which can be either orographic, it can also be convection, it can be convergence, it can be quite a few things. However, the 3 key things are needed: humidity, unstable air, and the trigger. So of course, in this case, in order to have the unstable air, we need the lapse rate to be greater than saturated adiabatic lapse rate. We need high humidity and an initial lifting process, of course, meaning this answer is the correct one. Just to show you before we continue an example of the thunderstorm. So here you can see it is a clear example of an orographic thunderstorm, which has a trigger that is orographic. Of course, the air is being pushed up initially by the mountain in the way, and as the air is being pushed, then the convection starts, the whole process begins, And of course, a big thunderstorm cloud is being created. The stages of the thunderstorms is also something that you have to know for the exams. So a quick recap: we have the building stage, we have only uplifting air going up, then the mature stage where we have air going both up and down, and then lastly the longest, the dissipating stage, where the air is only going down. There we have long, relatively constant precipitation. Remember that the mature stage is the most violent one. This is also where we have all the lightnings and thunders. I'm now going to question number 4. So in a METAR message, the wind group is 230 degrees, 10 meters per second. This means, remember that roughly 1 meter per second, in order to get the knots, we can multiply it by 2. Not exact science, however, it gets the job done for the exams and general flying. So of course here we're looking for an answer 230 degrees and 20 knots. And remember that everything that is written in aviation will always be true, and what is spoken will be magnetic. So if we have METARs and TAFs, all the directions will be given in true. So wind 232 at 20 knots. However, if the information about the wind is given from the ATC or even from the ATIS, because it's spoken, in that case it will be magnetic. The only exception here is of course the volnet, which is transmitted via the HF frequencies in most cases. Here they are transmitting METAR messages, so this is the only case where you will hear a true windy direction, but this is only because the METARs are just transmitted audibly. In all other cases, what's written will be true, what is spoken will be magnetic. So question number 5, the difference between geostrophic wind and gradient wind is caused by. So remember that there are a couple winds and wind models that you need to remember for your exams. The geostrophic, the most basic wind, is essentially a balance of the pressure gradient force and the Coriolis force, which give us the wind direction. The Coriolis force, of course, has to do with the Earth spinning. Then the gradient wind model adds one more force. Of course, the air is blowing, as you probably remember, clockwise around the high pressure areas and anti-clockwise around low pressure areas. And this turning of the air, of course, creates another force, which will be the centrifugal force, the force that has to do with the turning of the airflow. And this is what the gradient force takes into account. And then we have the last one, which is the surface wind model. And this is the wind in which we also take into account the friction force, so the friction between the earth and the wind and the air molecules. The surface wind model will only be applied up to around 2,000 feet. Any higher than this, we do not have the friction really there. Remember for these exams that for the surface winds, because the land is more coarse than the sea, it will always be more slowed down and there is more friction. So over sea, the wind will be around 70%, the surface wind will be around 70% of the one aloft, and on the land around 50%. So if you have 10 knots, of course, it's 7 close to the ground and the sea or oceans, and 5 over land. And then because the speed is also changing, the Coriolis force is changing, so it will be veering around 30 over land and 10 over the sea. So of course the difference between geostrophic and gradient is the addition of the centripetal force, which has to do with the curvature of the isobars or with the turning of the air around the pressure systems. For question number 6, which aircraft is experiencing the greatest headwind when flying close to the surface? When you see these questions, first of all, try to locate the hemisphere you're flying at. You can see with the latitude and longitude lines 10 west and 40 north, clearly here we are in the northern hemisphere. In the northern hemisphere, around the low pressure area, the air is blowing counterclockwise in the cyclones, and in the anticyclones, which are the high pressure areas, the wind will be blowing clockwise. This is reversed in the southern hemisphere, so be careful for the exams. And of course here, the wind is blowing anti-clockwise, so aircraft A and Charlie are experiencing headwind. And then, of course, remember that wind is always strongest because the pressure gradient force is strongest where the isobars are closest. So, of course, the stronger wind, because the closer isobars are near the aircraft Charlie, will be exactly there. And now for question number 7. So, which of the following statements concerning trade winds is correct? Remember, the trade winds are winds that around the equatorial area, the ITCZ, there is a lot of surface heating, so a lot of air is being pushed up, and this is also why around these areas we have a very adverse weather and thunderstorms. Because this air is being pushed up, it creates a low pressure area underneath. This low pressure area is being filled by the air coming from the sides, and of course this is a big cycle of air going up, then down and up on the globe, back subsidides and connects back at the ITCZ. These winds that are coming from the higher pressure areas towards this low pressure zone that is created by these convective activities are called the trade winds. And of course, although the air going up, the convection around the ITCZ can reach very high levels of the tropopause, over around even 55,000 feet, the trade winds itself are replacing the low pressure area underneath closer to the surface. And these low pressure areas being replaced by this air is of course felt by us as horizontal winds, and then they go back up in the middle. So this, of course, they will occur in the lower part of the troposphere because this is air replacing the low pressure area underneath, and will be much more pronounced around the oceans because, again, as we mentioned, there is less friction force over oceans than over the continents. And for the last question number 8, a jet aircraft flies down of a large CB cell and notices small water droplets on the windshield and unreliable indications. Despite flying in clear air well outside the cloud, what type of icing is possible? In this case, these are all the indications of ice crystal icing, because if the ice crystals are hitting our windshield, which is heated, they will usually melt and we'll have this rain-like feeling. Also remember that flying downwind of a large CB means that the crystals inside of the cloud are being pushed by the wind out. So this is a very clear indication that we have ice crystal icing downwind of the CB and little droplets high in the air. However, other type of icings are also worth noticing here, as you need to know all of them for the exams. Remember that the clear ice will be created by small supercooled water droplets because they will freeze almost instantly, and we'll have very clear and glass-like ice. The rime ice, on the other hand, will be created by large supercooled water droplets, and because they are larger, they will freeze a bit slower, and this slower freezing will mean that we can actually expect some air to be trapped inside, and as the air is being trapped inside, you have this milky, glossy type of ice. And this will be pretty much everything. Lastly, remember for these questions that the icing conditions where the supercooled water droplets can exist will be anywhere from around 0 to minus 15 degrees for the exams. However, for real life, you can expect them to exist to around minus 40. And this is everything for today. So thank you very much for tuning in and joining us today. I wish you all the best. I highly encourage you to get the Airhead account to see all the questions yourselves and much more. I hope to see you in the next video. Have a fantastic day and bye-bye.